For today's review video, I'm going to be talking about the topic 10.2 Taylor series. So before we get into it, we're going to go over some concepts, basics, review, rules. So here I have three scenarios for three limits. We have the limit as x is approaching infinity, which also, reminder, means from the right. 5x squared plus 6x plus 9 over 2x squared plus 8. So to find the limit, an easy thing we can do is to look at their power for the first term. And since the power for the first um, term for the numerator and denominator are the same, our answer is just 5 over 2, which is the first number. And this is when the top equals the bottom, meaning they have the same power. So now in scenario 2, where that is different, we have 9x squared plus 7x plus 4 over 3x to the power of 9 plus 6x plus 8. The top power is less than the bottom, and whenever that happens, our answer is going to be 0. Now our last scenario is when the bottom power is less than the top. And so here I have 9x to the power of 8 over 3x cubed. Whenever that happens, I'm going to get an answer of infinity. So let's look at a quick example. I have the limit as x is approaching infinity, 3x plus 3 factorial over 3x plus 4 factorial. Remember, factorial just means the numbers getting multiplied in decreasing order. So real quick, for example, if I had 5 factorial, that would just mean it's 5 times 4 times 3 times 2 times 1. I don't know if I explained it super well, but it's just numbers getting multiplied together in decreasing order. Okay, so to solve this for the factorial, I would have 3x plus 3 times 3x plus 2 times 3x plus 1 over, and then here I'm starting with 3x plus 4, and then times 3x plus 3, 3x plus 2, 3x plus 1. Now I see a lot of things that can be canceled out, but I still have this 3x plus 4 in the denominator, which means I have 1 over 3x plus 4. When I have something left over in the numerator or denominator, that means there's an extra power in there. So this would correspond with our second scenario that we just looked at, where the bottom is greater than the top, which means we would just get an answer of 0. So this scenario is how we got our answer here. Okay, let's look at a quick problem to solve. Okay, the Taylor series at 0 for f of x equals e to the x is 1 plus 10x plus 100x squared plus so on plus 10 raised to the power of n times x raised to the power of n. So in my last video, I mentioned how it's very important to look for patterns in an equation, and this is exactly why. all of this is simplified into this. This is the pattern for how we get all of this. 1 plus 10x plus 100x squared and so on is just from this formula over here. Okay, so let's solve this. To do so, there are 4 simple steps. The first step is to find a of n and a of n plus 1. So my a of n is, I look at my equation and it's the first thing that has an n in it, which in this case is my 10 raised to the power of n. I don't pay attention to the x raised to the power of n. I only want to pay attention to the 10, okay? So my a of n equals 10n, and then my a of n plus 1 equals 10n plus 1. I just add a plus to it. Okay, and now for step number 2, I'm going to find a of n plus 1 divided by a of n, which is 10n plus 1 over 10n. And I'm actually going to go ahead and separate these two. So I would get 10n, 10 to the 1, divided by 10 to the n. And separating is just going to make it a little bit easier when we get to step number 3 and 4. Okay, so now we're going to find the limit. So the limit as x approaches infinity, 10 to the power of n times 10 to the power of 1 over 10 to the power of n. That's why it is so important to separate your multiplied numbers and factors. It's because now, like when we were finding our limit up here in our example, we can just cancel stuff out. So I see 10 to the power of n in the numerator and denominator, so I can just go ahead and cancel that out. And I would have 10 to the 1 and I would get an answer of 10. Okay, so step 4 is to solve and interpret our results. When I solved for my limit, I got an answer of 10, which is greater than 0. So my 10 is my L, and then my R would equal 1 over 10. And now we are going to determine if it's going to converge or diverge based on my results because did not get infinity, it's going to um converge, but we need to find the intervals for that, which is why L and R right here is so important. So our answer from our limit is 10, that's our L, and then it's just 1 over that number for our R. So our interval of convergence is negative 1 over 10, x, or less than x is less than positive 1 over 10. And that is our interpreted results. So this was Taylor series and some rules and some rules about it and a few examples.